Good morning, everybody. Welcome to one of our last sessions. It's very close to the end now. We essentially have 3 sessions left. We'll talk about some basic word problems where variables and equations can be used as an effective solution or a problem-solving strategy, rather. Then I'll talk about a specific kind of word problem, equation, which comes up a lot in word problems. And then we have more word problems as sort of a third group at the end. So 3 sessions, ideally. Let's get started. Now, I'm not going to do 16.8 as the first one. I want to warm up a little first with something like 16.9. So let's read it and then see. David has 3 times as much money as Rick. Together they have $400. How much money does each one have? Again, it's not the most complicated questions to start with, and you can certainly feel like you can just do a guess and check strategy and get to the answer because the numbers are convenient. We don't need to make everything super complicated. But it is reasonable to expect that a guess and check strategy won't work for very long, so it's not something I can rely on. What would I do? Now, I'm not, again, going to drag the questions back and forth. Please open it uh, or do something so that you can refer to it when you want to, or you can just listen. Okay, so we have David and we have Rick. Together they have some money. I want to know how much does each person have. Now, it seems as if we have two variables because we have two people. But let's see here. Let's start with Rick, for example. Let's say R represents the amount of money that, I'll squeeze it in, Rick has. Nice full sentence. I'll say again on the record, if you say let R or whatever symbol equal Rick, that's not correct. And it doesn't show me or convince me that you understand what a variable is. This says R is a person, but that's not true. R is a number that is the amount of money that corresponds to Rick. So be clear, take that extra time, and get the marks that you should get. I have zero tolerance for people being lazy in this first step and not writing a sentence. So let's just see. If R represents the amount of money that Rick has and David has 3 times as much, I don't need a new variable. I can say then David has 3 times R. Oop, that's not a good R, I'm sorry. Let's try better with my R's. It's marginally better. So I can use the variable that I defined to write an algebraic expression to represent the other unknown quantity. Let's say here dollars, I suppose. And it's always going to be a little bit more convenient for me to, if I can get away with just one variable, I'm going to try and do that. It's not always possible, but for our level of questions, it's almost always. Okay, so that was step 1. Now, let's translate the information. They say together they have $400. So again, I'm looking at breaking it up into David and Rick, adding them up, and that should equal 400. dollars. So the amount of money that Rick, oh, my R is horrible. The amount of money that Rick has plus, now I'm overthinking my R's. The amount of money that David has to equal 400. And there's my information translated into the mathematical language by way of an equation. Now I look at this equation and see, oh, okay, I have 4 R's, and that equals 400. Divide both sides by 4, so R equals 100. So I look at what the equation requires, and then then I act accordingly to figure out what the value of the variable is. So on the mathematical side, I only have an R, and it's 100. I now have to interpret that to make sure I answer the question that they had. And they want to know how much does each person have. So I can say, Rick, I guess first. Rick has R. That's exactly what R represents. Let's go with dollars, $100. And David has $300. And I can do a quick check. Oh, does it add up to 400? Yes, it does. So I'm good to go. But I still have these 4 steps that I can rely on when things get more complicated, perhaps. And everyone's different, right? For some, this is already complicated. Totally fine. For others, they maybe have a good sense of these things and can quickly guess and check in their head and see, oh, it has to be 100 and 300. But the numbers are so nice that you can maybe get away with that. Don't rely on that for very long. Have a backup when numbers are unpleasant, or I don't know what to do. Let these 4 steps guide you. It's a problem-solving strategy that should technically be in chapter 3, if you think way back, general problem solving. But at that stage, we weren't necessarily ready for it, so I make it a separate topic at the end. All right, let us see the next one. One weekend, a store sold twice as many CDs as DVDs, 25 fewer tapes than CDs. Let X represent the number of DVDs sold. Oh, so this is nice. They do step 1 for me. How nice. They're so nice. I want to express the number of CDs and tapes sold in terms of X. How many of each were sold if 100 items were sold in total? Okay, let's one thing at a time. I have 3 unknown quantities here. They define X to represent the number of DVDs, but I also want to know the number of CDs and tapes, whatever cassette tapes are. No one even remembers them. But still, I have 3 things, and they only define the first one of them for me, the number of DVDs. And that's okay. So we could say here, I don't have to redo step 1 completely, but there is a little bit more to say, and just to help myself. If X represents the number of DVDs, then I can use that variable to try and represent the other quantities that are unknown as well. I don't need to define new variables, new. It makes things unnecessarily complicated. If I can avoid it, then I'm going to. So if X represents the number of DVDs, then the number of CDs, they say a store sold twice as many CDs as DVDs. Then let's say here the store sold 2 times X CDs and 25 fewer tapes than CDs. 25 fewer tapes than CDs. So I need to subtract 25 from the number of CDs to get the number of cassette tapes. I'll put brackets around those if you want to. It's one representation. So I've used the one variable to represent all the unknowns. That's going to be much more convenient, but I need to write that out for myself. Then They say there is 100. Oh, this is actually part of the question in this case. I do have to check the question carefully, right? They say express the number of CDs and tapes sold in terms of X. So I kind of had to do that. But anyway, it wasn't just for myself. Okay. Then they say they sold 100 items in total. So obviously, if I add up the number of DVDs, CDs, and tapes, I should get 100. So the more I do these things, especially at the same level of difficulty, you start to see certain translation aspects repeating themselves. So I don't have to be too detailed here if I don't need that help. Number of DVDs plus number of CDs plus number of tapes equals 100. Now I just have to figure out what the value of x is. So I have here 5x's. So I simplify both sides first. Then I'll see, okay, how can I isolate the x systematically? I add 25 to get 5x equal to 125. Then I divide both sides by 5 to get x equal to 25. Now it partially answers my question. I have 3 unknowns though. I want to find the number for each of them. I have the number of DVDs because that was exactly x. So I can say here, the store sold 25 DVDs. Now I have to check. 2x represents the number of CDs, so 2 times 25, that's 50 CDs. And 2 times x, so 2 times 25 is 50, minus 25, 25 tapes. And I can check, do they add up to 100? Yes, they do. So I feel pretty good about that. Again, the 4 steps. Step 1, partially done for me. They gave me the variable, but then did ask to represent the other 2 unknown quantities. So half of it, I guess, was done. Translate to an equation. Solve whatever that equation requires, or solve it in a way that that equation requires, following the rules of what I can do to simplify equations, and then write a concluding sentence. 4 steps, no more, no less. All right, so with some repetition, I hopefully get the hang of it. It just takes time, and it takes a different amount of time for different people. Maybe you're someone that already feels comfortable with all of this, and that's great. Or maybe you're someone that needs a little more, and that's fine as well. Let's look at 16.8 now. See what it can teach us. A bottle of wine costs $10. The wine was worth $9 more than the bottle. How much was the bottle worth? So if you were to ask someone, and you can experiment with this if you know of someone, just ask them this verbally. Say, a bottle of wine costs $10. The wine is worth $9 more than the bottle. How much was the bottle worth? And if you ask them to answer quickly, I think most people would say $1 because they think 10, they think 9, the gap is $1. Let's see if we analyze this a little bit more carefully. How our intuition might not always get us to the correct answer. So exercise 16.8. So a bottle of wine costs $10. So I have the wine inside and then the bottle as well, the glass or whatever material it is. So I have to pick one. Let's go with the bottle. Let's say I just use the first letter in the word because it helps me remember what the variables mean as well. Let B represent bottle. No, it represents the cost of the bottle, the value of the bottle, whatever. Represent the cost or value or whatever of the bottle. Then I have the value of the wine inside, and they say the wine was worth $9 more than the bottle. So then the wine itself is worth $9 more than the bottle, so B plus 9. That's exactly what they say. $9 more than the bottle. It is right here. So I'm simply, in that sense as well, I'm still translating just pieces of this. Wine was worth $9 more than the bottle. All right. So now they say in total the bottle of wine, so the bottle with the wine, costs $10. So obviously when I add these two up, right? Now the bottle plus the value of the bottle plus the value of the wine equals $10. Now I just look at this equation completely out of context. What does this equation require me to do? Simplify to 2b plus 9 equals 10. Subtract 9 on both sides. So I have 2b equals 1. So b, I can show it. Divide both sides by 2, and b equals a half. Or I can, because it's a dollar value, I can say 50 cents. So the bottle costs 50 cents, and the wine is then $9.50. Contrary to what my intuition may have wanted me to say. So let's say that here. The bottle costs, let's say 50 cents, and the wine costs $9.50. And you see that the wine is $9 more, and together they do add up to $10. So it matches all the information that the question gave me. It's just, in general, my intuition wanted to say that the wine costs $9 and the bottle costs 1, especially when I try and do things quickly. But if I analyze this with my 4-step process, then the truth comes out. So it's not a matter of what I feel or what I think. It doesn't matter. There is a backup, systematic, logical method to get me to the answer that I can rely on. I don't have to have an intuition. I don't have to have a sense of these things and just magically see them in my head. No, it doesn't work like that. Well, I guess for some people it does, but from a teaching point of view, it's useless. I need to be able to explain myself systematically and then have the benefit that when I encounter a problem that I don't know right away, which for me is most problems, I have that confidence that no, I'll just go through my 4 steps and the answer will show itself. I don't have to worry too much about it. It's outside of my abilities almost. It's not dependent on how I feel on the day. It's not dependent on if I just magically see numbers in my head. No, that's nonsense. There's a method, there's a recipe, and I will follow the recipe and get the answer. You get the analogy is you get people that maybe they can uh, bake very well without a recipe. They just have a sense for how much sugar and how much milk and eggs and all those things should be combined, and they create delicious things. But they're just going on their sort of intuition. They can't explain how to do it. They can't teach anyone else. They might be amazing, but it's sort of just for them. And I can't really share that wisdom. Whereas other people can make the same things, just follow the recipe. And you don't have to have that magical ability. It doesn't make you better or worse. There's nothing to worry about. All right, we did 16 10. We have 4 more we're trying to get through. I think we're on time. I don't want to rush it, but I do want to get through these 4 problems. And I think we should do that easily. Let's read 1611. And of course, if you feel I'm going too fast, then of course watch the video again and pause it and do whatever you need to do, of course. I just want to finish this section nicely in one session. In a small town, 3 children deliver all the newspapers. Abby delivers 3 times as many papers as Bob. Connie delivers 13 more than Abby. If the 3 children delivered a total of 496, how many papers does each one deliver? So you see the same kind of information pops up that I need to be able to represent by way of variables the number of papers each person delivers, and then I'll obviously add them up because they give me a total. So I have the similar things that occur, and the more questions I do, the more I see that repetition and I build my experience, and it does become easier. So often when I'm working with integers, the one I'll go for to define my first variable is the smaller one. It doesn't have to be. It's just going to make the other expressions as simple as possible in appearance, but it's certainly not a rule that you must follow. So Abby delivers 3 times as many papers as Bob. Connie delivers 13 more than Abby. So it seems like Bob is the one that did the least. So let's go with B for Bob. Let B represent Bob? No. Represent the number of papers Bob delivers. Delivers. Okay, full sentence here. Then, can we represent the number of papers the other people deliver using this B? Again, I don't have to, but it's going to be much more convenient if I minimize the number of different variables that I have to work with. So then Abby delivers 3 times as many as Bob, so 3B papers. And the other person is Connie. Connie delivers 13 more than Abby. So that's represented by 3B plus 13. So using the one variable, I'm able to represent the other quantities as well. Whether they ask it or not, it's part of my step 1. All the unknowns that I need to be represented either by a new variable that I define or by previous variables adjusted in some way. So now I have the information that if they deliver a total of 496 papers, I'm obviously going to add these up because I have experience from previous questions where the same kind of translation occurred, and it does get easier. Now I look at this equation. It doesn't matter where it came from. Within the mathematical language, I have rules to simplify this equation. I have 7b's plus 13 equals 496. Oh no, what are they? Not 1496. Get out of there. It's a good idea when you simplify equations to just do one thing at a time. Don't merge the b's and subtract 13 at the same time unless you're super confident. Mistakes can very easily happen. But if you do one thing at a time, then it's not so bad. So 496 minus 13 is 483. Feel free to use your calculator if you want to be confident, because we definitely don't want to make a little mistake here, and then that carries forward, right? Divide both sides by 7. I'll show that in the chat. Just to have something in the chat, it's nice. 483 divided by 7. Get rid of that line. And we have 69. That was only B for Bob. Bob delivered 69 papers, but I'm ready for my concluding sentence. So, Bob delivered, or delivers, I don't know, delivered 69 papers. Abby is another one. She delivered, now I have to go look. The amount of papers that she delivered was represented by 3B, so 3 times the value of B. I can do that in the chat, sure. 3 times 69. 207 papers. And lastly, Connie delivered, now I have to go look, 3B plus 13. So 3 times 69, which I have there, plus 13 is 220, right? Papers. And I can check if I add these up, do they add up to 496, just as a little safety. But it should be good. We can do that just to be sure. 69 plus 207 plus 220, and we get our 496, as we should if we do everything correctly. Again, they start to repeat themselves in terms of the process and what it looks like, but that doesn't mean they're always going to be the same, right? They're not always going to give me the total. There is some variety, but certainly among this difficulty level of questions, it does start. There's some things that do repeat, and that makes it easier and builds my experience. All right. 1612 is the next one. 3 brothers, Tom, Dick, and Harry, ate a whole apple pie. Tom ate twice as much as Harry, and Dick ate 1.5 times as much as Harry. What part of the pie did each brother eat? All right. So now I want to know, in order to answer this question at the end, I want to be able to say a sentence like, Tom ate this much of a pie. Harry ate this much of the pie. Dick ate this much of the pie. There's only one pie. So if I think about, and it's useful sometimes, think about how is my concluding sentence answer going to be phrased? What is it ultimately going to say? Ultimately, I want to say Tom ate a certain fraction of the pie. There's one pie, and they each get to eat a fraction of it. So my answers are going to be fractions, proper fractions, because they only eat from one pie. Okay. So I'm going to have 3 of them, but I want to pick one, and then hopefully I can represent the other portions that the other people eat in terms of that first variable. So in the case of fractions, in my experience, again, it's not something you must do, but it might be useful to pick the largest of the values. Whoever eats the most, let that be my variable. But again, it doesn't have to be. Sometimes it makes the other expressions a little nicer, but it doesn't have to be at all. Let's just start. I think Harry is going to be the nicer one to start with in this case, because Tom is the amount that Tom eats, or the portion, is sort of defined in reference to Harry. And Dick's portion is also defined in reference to Harry. So it's going to save me a little bit of effort if I just start with Harry as my uh, variable. So let's see. So the rule doesn't always work. I was a little hesitant to to say, but when I work with numbers in general, uh, just pick one of them to start with. That's going to make the others most convenient. Let's go with that. Sometimes the smallest, sometimes the biggest, sometimes something in the middle. I look at the sentences and see which one would be the most convenient to start with. I think Harry. Let's go with H. Let H represent not Harry, but the, let's say here, fraction or portion of the pie that Harry ate. And of course, if you start with a different person, your initial steps will look a little different, but the end answer will be the same, of course. Then they say Tom ate twice as much as Harry. So Tom ate 2h of the pie. And this is going to be some fraction. 2 times the fraction that that corresponds to Harry. And they say Dick ate 1.5 times as much as Harry. So you can write here 1.5 times h. I like the times here because in a calculation there really shouldn't be mixed numbers. Mixed numbers is a presentation uh, thing. So I'll rewrite this to 3 over 2h. When you do calculations, use improper fractions or decimals if you really like decimals. But fractions are going to be nice here in order for me to conveniently say my concluding sentence. So 3 over 2h, which is going to be a fraction of, oh, I already wrote of, of the pie. Okay, so now it is similar in that I'm going to add up these quantities. However, they don't tell me what the total is, like they did for the papers previously, right? So if I add them up, what should I get? I get the 1 pie. All of them eat a fraction of the pie, and that should add up to 1. So the fraction that Harry eats plus the, let's say Don here, is it the M? The fraction that Tom eats plus the fraction that Dick eats should add up to 1. So there's some variety right there. So now I look at this equation, see how I cover the rest. It doesn't matter where this equation comes from. I kind of forget. What does this equation require me to do? Well, I have 1h here. I have another 2 h's, so that's 3. I have another 1.5 here. So that is, let's write it on the side here. 1 plus 2 plus, you can say 1.5 or 3 over 2. Doesn't matter to me. It doesn't matter. I'll make 1.5 because it's easier when we think of it maybe to do it in our head. That's going to be 4.5. Now, I don't want to see the mixed number in here, so I want to convert that to an improper fraction. So 9 over 4, not 9 over 4, 9 over 2. 9 over 2. So 9 over 2 times h equals 1. So I'm going to divide by 9 over 2, divide by 9 over 2 to get h alone. And when I divide by a fraction, we've saw the pattern that it's this equivalent to multiplying by the reciprocal, so 2 over 9. So that gives me h, and I think I'm ready to write our sentence. So Harry ate 2/9 of the pi. Who was next? Tom, 8. I have to go check. Tom ate twice as much. Tom was hungry. See? So that would be 4/9 of the pi. And lastly, Dick ate. Let's go see. Well, I know it should be the rest, but I'll use that to check if they add up to 1. Dick ate 3/2 times h, 1.5 times h. What's h? H is this guy. So now different ways to go about this. Let's just go up here where we have the space. I don't want to do a calculation in my concluding sentence. I just want to say the answer. 1.5 times 2/9 is going to be 3/9 because I take the 2 and then another half of the 2 is 1, so 3/9. So this is going to be 3/9. And it's nice uh, to have the denominator be the same so I can easily check and compare the fractions. Or you could have said here, well, I have 3/2 times 2/9. That is going to be, oh yeah, the 2's cancel. I get 3/9 as well. So it doesn't even matter. But it's nice here to have the same denominator for comparison purposes. 3/9 of the pi. And then I can see, oh, does this add up? 2 plus 4 is 6, plus 3 is 9. So whole pi was consumed by these 3 people. Let's zoom out a touch, maybe. Well, that's maybe a bit too much. What's a bit too much zooming? Something in the middle? Sort of. So with fractions, like anything, like any other problem involving fractions, I need to slow down a little bit and just be careful. But the same 4 steps are still there. Some people may be a little bit confused, like they didn't tell me what it adds up to, because it's all in reference to a pi. So it adds up to 1 whole pi. All right. I understand that perhaps I'm going a little fast. Rewatch the video over and over and over and over, as many times as you need. Let me know if you have any questions after the fact. I just want to really finish this grouping of questions in one session. Okay, let's see the next one here. I'm gonna do 16.14 next. Kai, Paul, Judy made $2,520 for painting a house. Kai worked 30 hours, Paul worked 50 hours, Judy worked 60 hours. They divided the money in proportion to the number of hours worked. If they all earned the same rate, how much did each person earn? So really, I just have to look at the phrasing. How are they presenting this question? And then I think, okay, what are they looking for? Well, it's pretty obvious. How much money did each person earn? But that doesn't mean I have to calculate with that specific quantity and number. I simply have to eventually give an answer that Kai made this much money, Paul made this much money, Judy made this much money. How I get there is up to me. I just need to be able to say it in that way at the very end. So because they earn the same rate of pay, if I know what that rate is, dollar per hour, then I would immediately know how much each person makes because they tell me the hours for each. So in terms of convenience, that's going to give me a much easier time through this problem because I'm trying to get just one variable, right? So questions are a little different sometimes. Let's say, let's go little r, and that represents the rate of pay. So that'll be dollars per hour. And it's the same for all of them. So then I'm not quite done because I need to represent other quantities. Kai earned $30. Oh, sorry, he works for 30 hours at R dollars per hour. That's multiplication. So let's put a dollar sign here. 30R. Maybe the R is going to bother some people. Let's make it an X. Maybe people feel more comfortable with an X. Make it an X so it stands out. It's all curly and stuff. That's one. Paul, they say, he works for 50 hours at X dollars per hour. That's going to be 50 times X, representing his total dollar amount. And Judy is the last one. She worked for 60 hours, same rate, so 60 times X. So by choosing to represent, to have a variable that represents the rate of pay, I can very easily get quantities for all the dollar amounts. Now they say that together they made a certain amount. I'm just going to add these up. And that has to equal the total amount that they made. So there's some similarity, but maybe a little different in terms of how the variable is defined. So now I just look at this for what it is. I have 30 x's, I have 80, I have 140 x's equals 2520. Divide both sides by 140. Let the calculator worry about exactly what that is. 2520 divided by 140. Random line. 18. Now, if I got some decimals here, that doesn't mean it's wrong, but sometimes these questions are set up to have a nice round answer. And I think good. I can go up here if I want to. And remember, 18 is the rate that they get. Go up here and then say, oh, this is then 30 times 18, 50 times 18, 60 times 18. Because I don't want a calculation in my concluding sentence. So I can say 30 times 18, which will be $540. I now know. 50 times 18, $900. And 60 times 18, one more, 1,080. And then my concluding sentence is a little cleaner. So, Kai earned, I'm just repeating it, right? But it's a nice place to have all the answers for someone that doesn't want to look at the math. They still just want to know the answer. It's nice to summarize it. It's just a good habit. And lastly, Judy earned 1,080. And you can add them up and make sure they add up to the total and all that. So think about the key and the most difficult portion of questions like this is to get the variable that sets me up for success and is the most convenient. There might not be just one answer for that, but that's where the thinking really goes. Once I have the equation, it's all done. And that equation can become easier if I put some thought into the variable. What am I going to use? What am I going to call it? What is it going to mean? How can I represent other quantities in terms of it? I don't have as much time as I would have liked for 1613, so I apologize in advance if this is too fast for you, but I want to get everything in one session here. So feel free to rewatch the video. Let me know afterwards if you have any questions. Bruno has 5 books overdue at the library. The fine for overdue books is 10 cents a day per book. He remembers that he checked out an astronomy book a week before he checked out 4 novels. So he has 4 novels and an astronomy book, and his total fine is $8.70. How long was each book overdue? So here we want to write our final answer, our concluding sentence as the novels were overdue this many days, the astronomy book was overdue this many days. So that certainly lends me to think that a variable to represent the number of days is going to be convenient because the fine is also per day. So let's just pick one randomly. Let's go A for astronomy. A doesn't represent astronomy. It represents the number of days the astronomy book is overdue or was overdue. So writing out this full sentence helps me as well remember what this A represents. Then, of course, I have novels as well. Well, Bruno has some novels. And they say that he checked out the astronomy book a week before he checked out the novels. So he had the astronomy book for longer, 7 days longer than the novels. So the number of days that the novels will be overdue is going to be less. So then the novels are overdue. I don't know what tense is here. Were overdue A minus 7 days because the astronomy book came first. So there's a bigger gap between now and when he took it out. And the novels were more recent. He checked out the astronomy book a week before he checked out the novels. So the novels weren't overdue that many days, a week less. So now I want to make a plan for my translation, my equation, and it's going to be the total fine. Total fine. I'm planning. It's going to be the total fine for the astronomy books, astro fine, let's say, plus the fine for all the novels, and that's going to give me my total fine, of course. So it's 10 cents per book per day. So, but there's only one astronomy book. So let's just do the right-hand side first. The right-hand side is going to be $8.70. So now my unit here is the dollar. So I have to make sure that I represent everything in dollars. I have to speed up a little bit. But even if we just get the equation, the rest should be straightforward. So 10 cents is going to be $0.1. $0.1 or 0.10 if you want per day. And the astronomy book was taken for A days. And that's the cost. The novel is also 10 cents a day. And the novels were overdue A minus 7 days, but there are 4 of them. So the total fine is going to be times 4. And there's my equation. A few more pieces to it, but it's still there. So now I need to simplify this. I'll multiply the 4 first here, maybe just to not skip a step. And that's $8.70. Then I want to multiply the 0.4 in here. Not an equal sign there, plus obviously. 0.4a minus 0.4 times 7 is going to be 2.8. Check your calculator if you want to. So now I have 0.5 times a minus 2.8 equals 8.7. I don't need that 0 there. I don't know why I keep doing it. Plus 2.8 on both sides. So 0.5 times a. What is that? That's a 10 and another 0.5, 11.5. And then I divide both sides by 0.5 to get a equal to, oh, let's show that. Maybe that's not as obvious as the others were. 11.5 divided by 0.5, though if you think about it a little bit, 23 is not the hardest thing to come up with. So this gives me, I know I'm over time, I just want to finish this, the number of days the astronomy book was overdue. Astronomy book was overdue 23 days, and the novels 7 days less, 16 days. Let me zoom out a touch. So it's really all about defining a variable and then defining everything I need to define in terms of that variable, if I can, and setting up the equation using that first step. Once I have the equation set up, the rest is just sort of mechanical. There's no flexibility in how I solve the equation and write my concluding sentence, really. It's setting myself up for success. That's where, in the beginning, is where the thinking goes. And the more effort I put in there, the better the rest of the question will become. I know that one was a little fast, but I wanted to have this one group at the same time all together. Let me know if there are any questions. Otherwise, we will pause here to continue our discussion on the next type of equation next time. So rewatch the video if you need to, think about it, and let me know if you have any questions. Until next time, thank you.